Welcome to the future. This timeline is amazing. The global Hyperloop network is finally complete. The bioengineered glow-in-the-dark redwood forest in the Sahara is a vacation paradise. And best of all, we have colonies throughout the solar system. One thing that might surprise you about the future is that everyone still uses SQL. I didn't see that coming. So to prepare you for the future, we now explore an essential part of SQL: joins. The database we will be using to learn about joins has 5 tables: Martian, Base, Visitor, Inventory, and Supply. The Martian table is a list of all people living on the red planet. After all, if you are living on Mars, you are no longer an Earthling. You're a Martian. The Base table holds information on all the different habitats on planet number 4. In addition to serving as a stopover for people visiting the outer planets, Mars is now a tourist destination. Every visitor to Mars is tracked in the Visitor table. The Inventory table keeps track of the supplies at each base. And the Supply table shows what is available at the Central Martian Distribution Center. Let's take a closer look at the Martian and Base tables. Here are the columns in the Martian table. The Super ID is the ID of the Martian they report to. And here are the columns in the Base table. These two tables are connected because each Martian has a base ID identifying where they live and work. Suppose you need to generate a report listing the full names of all Martians and the name of their home base. How would you do it? The Martian name is in the Martian table, while the base name is in the Base table. The solution is to join these two tables together by the base ID. To begin, look at the data in the Martian table and the Base table. Let us visualize how to join these tables together by the base ID. Take the first row from the Martian table, find the row in the Base table with a matching base ID, and then join them together to make a new, larger row. You continue doing this row by row by row. This brings us to John Carter. He does not have a base ID. So what do? Do we include him in the join or leave him out? This is a very important question. The answer depends on the type of join you do. For now, we will leave John Carter out. The result is 12 rows. Each row is a combination of data from both tables. Having joined these two tables, you can select data from these rows like an ordinary select query. By the way, notice that there is currently no Martian at the Olympus Mons Spa and Casino. This is because the staff is en route from the moon and will not arrive for a few more weeks. Here's how to write a join using SQL. Begin with select star so we can see all columns. This will help in understanding the join. Next, specify the two tables. From Martian, inner join Base. We will call Martian the left table and Base the right table. The join keyword indicates we will be joining these two tables. We'll explain the inner keyword in just a moment. Next, specify how to connect two rows from these tables with an ON clause. We only want to connect a Martian row with a Base row if they have the same base ID. In the ON clause, you have to specify both table name and column name. This makes it clear which table each column is from. Now execute. The result contains all the columns from the Martian table and all the columns from the Base table. The rows are matched by base ID. John Carter and the Olympus Mons Spa and Casino do not appear in the result. This is because neither one had a match in the other table. We can now update this query to return only those columns we need for our report: first name, last name, and base name. Execute. Report complete. When joining the tables, we encountered 2 problematic rows. John Carter is in the Martian table, but his base is unknown. And the Olympus Mons Spa and Casino currently has no Martians. So how do you tell SQL whether or not to include rows from a table that do not have a match in the other? We have 2 tables, and we have 2 choices per table. Include rows without a match or exclude them. This means there are 4 total options. Spoiler alert, SQL has a join for each of the 4 options. Let's visit them now. We return to the Martian and base tables. We will call the Martian table the left table and base the right table. Each table has a row with no match in the other table. Here's the syntax for joining these 2 tables. Write select, followed by the columns you want, from Martian, blank, join base. On Martian.baseID equals base.baseID. The on clause specifies how rows from the 2 tables will be connected. Because this is a select query, you can also have where and order clauses. All that remains is to fill in the blank and specify what kind of join to perform. We will learn about 4 types of joins: inner, left, right, and full. An inner join will only return connected rows when there is a matching base ID in both tables. A left join will return every row from the left table, even if there is no matching row in the right table. If a Martian row has no match in the base table, it will return nulls for all the columns in the right table. A right join will return every row from the right table, even when there isn't a match in the left table. When a base row does not have a matching Martian row, null values will be used for all columns in the left table. And finally, there is the full join. This is sometimes called a full outer join. The full join is a combination of the left join and right join. A full join returns every row from the left table and every row from the right table. When the base IDs match, the rows are connected. But when there isn't a match, the row is still included in the join with nulls for the columns from the other table. A common way to visualize the difference between these 4 kinds of joins is with Venn diagrams. The inner join diagram highlights how only rows with matching columns are connected. The left join diagram shows that all rows in the left table are returned, even those without a match on the right. The right join is the mirror image of the left join. And full join shows that all rows from both tables are returned. When 2 rows match, they are connected. Otherwise, nulls will fill in the gaps. I just received a Dear John letter. It's especially sad because my name isn't even John. It reads, Dear John, not every database supports the 4 joins you discussed. For example, MySQL and SQLite do not support full joins. Sincerely, R.E. Joinder. I will not be deterred. We are going to see examples of these 4 kinds of joins using Postgres. Maybe the other databases will join us? Before seeing examples for inner, left, right, and full joins, I would like to revisit our first query. Select star from Martian, inner join base, on Martian.baseID equals base.baseID. Execute. Notice how the output has 2 columns named base ID. The first one is from the Martian table, and the second one is from the base table. What if instead of selecting all columns from both tables, we only select the Martian ID, and base name? Execute. We get an error. This is because it is ambiguous which base ID column we want. Is it the base ID from the Martian table or base table? To avoid ambiguity, you specify the table and column name in the select clause. We will select the base ID from the base table. Execute. Success. Repeatedly typing the table name can make queries a bit wordy and hands a bit sorry. We can fix this by creating an alias for each table name. To do this, use the as keyword. If we write from Martian as M, then M is now an alias for the table named Martian. And let us give the base table an alias of B. Now everywhere in our query, we can use M instead of the table name Martian and use B instead of the table name base. The on clause becomes nicer and shorter, and the select clause is more compact as well. Now that you have properly been introduced to joins, it is time to see some examples. Not just 1 or 2 examples, mind you, but a lot of examples. But not too many. We don't want you to feel bored. Somewhere between not quite enough and way too many. That is how many examples we are going to see in our next video. So, Join me in the next video as we boldly go where no one has gone before. Okay, that's a lie. If you look at the number of views on the next video, you will see exactly how many people have gone before you.